Hello everyone, in this video I will talk about some basic probability concepts and calculations using coin tosses as examples. For all the questions, we're going to work with the simple normal coin, which means that when you toss it, it's going to either land on heads or tails. And it's also going to be a fair-sided coin, meaning that heads is equally likely as tails. Now for our first experiment, suppose we toss the coin once, only once. And our first question is, what is the probability of coin landing on heads? So whenever you're solving problems with probabilities, you first want to think about the total possible outcomes from the experiment. In this video, possible outcomes are the final results that you can get after completing an experiment. In our case, it's very simple because we only have two outcomes. One of the outcomes is coin landing on heads, and the other outcome is coin landing on tails. So then the total number of possible outcomes from this experiment is simply going to equal to 2. And here I want to quickly note that the outcomes from the experiment can also be called as events. Since I'm going to be using the term events a lot in this video, I want to spend a little bit of time explaining about it right now. So then what are events? Well, in this video, events are going to be some combinations of outcomes from the experiment. To give you an example of what events are, coin landing on heads would be one example. Another example would be coin landing on heads or tails. Another example is getting number of heads greater than or equal to 1. So as you can see from our question, all outcomes can be called as events, but not all events are outcomes. Example 1, coin landing on heads, is one of the outcomes from our experiment, but examples 2 and 3 are not outcomes. They just represent some combinations of outcomes. So that's what events are. Okay, now that we have the definition out of the way, we are now ready to answer our first question, which is, what is the probability of coin landing on heads? To answer the question, I'm first going to begin with the equation P of H, or probability of heads, is equal to maximum probability divided by number of possible outcomes from the experiment. And maximum probability is always going to be 1. So probability of heads is then going to equal to 1 divided by 2, or 1/2. And of course, you're not always going to use this equation for all the problems. You can only use it when you know that the probabilities of all the outcomes are all equal. And we know that's exactly the case for us because again, we're assuming that the coin is fair-sided, right? So then with all that being said, we can then say that probability of heads is also going to equal to probability of tails. Okay, then our next question is now asking, what is the probability that the coin lands on heads or tails? So this question is asking us to consider the event where the coin lands on heads or tails, right? And whenever you're trying to calculate the probability of an event that contains the OR statement, you're going to be adding and subtracting some probabilities related to the individual events. And whenever I say individual events in this video, I'm simply referring to the various results, or I guess you can also think of them as smaller results that make up the event that you are interested in. So in our question, the event that we are interested in is event A, the coin landing on heads or tails. And the various results that make up event A, coin landing on heads, and the other result, coin landing on tails, I'm simply calling them individual events in this video. Okay, so then coming back to our question, in order to find the probability of event A, all we have to do in our case, in our question, is to simply add the probabilities of the two individual events. And that's because the two individual events are two separate events. And when I say separate events, I mean events that cannot be satisfied at the same time after a completion of an experiment. In the textbook, separate events are called mutually exclusive events. Now, if this definition is a little bit confusing for you, you can also think about separate events as events that do not share same outcomes in an experiment. So looking at our question as an example, the individual event landing on heads and the other individual event landing on tails, they do not share the same outcomes, obviously because in our case, they happen to be two different outcomes in our experiment. Coin landing on heads is one of the outcomes, and coin landing on tails is a totally different outcome. So all of this means that the two individual events are separate events, which then means that we can simply add the probabilities of the two individual events in order to answer our question. So then now I'm going to say that P of H or T, which means probability of heads or tails, is equal to probability of heads plus probability of tails. P of H is simply 1/2, and P of T is simply 1/2 as well. So we're going to get that 1/2 plus 1/2 equals 1. Our next question is, what is the probability of coin landing on heads and tails? So instead of the OR statement, we now have an AND statement. And I'm going to call the event coin landing on heads and tails event B. So whenever you have an AND statement, you want to focus on the individual events and ask yourself if it's possible for the individual events to be satisfied together at the same time after completion of the experiment. If yes, then we have more work to do. We have to figure out what the probability is. If no, then probability of the event is going to be 0. In our question, after completing the experiment, after throwing the coin only once, if we get heads, then only one of the individual events is going to be satisfied, coin landing on heads. If we get tails, then only the other individual event is going to be satisfied. So in this experiment, where we throw the coin only once, we cannot satisfy both individual events together at the same time. This means that the probability of event B, or probability of heads and tails, is simply going to equal to 0, because that event is not possible. Okay, for our next question, I'm first going to erase everything. And now we're going to consider a whole new experiment where we toss the coin twice. So before we tossed the coin only once, now we're tossing it twice. So it's getting much more interesting. And keep in mind that the experiment tossing the coin twice is going to be the same as the experiment where we toss 2 coins at the same time. So what I'm trying to say is that although the procedure is a little bit different for these 2 experiments, the possible outcomes and all the calculations are going to be the same. So you can think about either one for the next couple of questions. And here I would like to make a note that for this video, whenever we consider multiple tosses, we're going to assume that tosses are independent. So usually whenever you see a coin toss problem somewhere, the independence between tosses are automatically assumed. In other words, usually the problems don't say that they're going to assume that tosses are going to be independent because it's going to be automatically assumed. But here, I just want to take a little bit of time to explain about the independence because some people may not be familiar with the concept. So when we say that coin tosses are independent, we are meaning that outcomes of tosses are not affected by each other. In our example where we toss the coin twice or throw 2 coins, this means that the outcome from one toss, heads or tails, does not affect probability of outcomes of the other toss. And of course, the other way around as well. And in probability, whenever events do not affect each other, like outcomes from different coin tosses, we say that they are independent events. So that's what we mean by independence. And in this video, the outcomes from different tosses are going to be independent. Okay, now we're ready to talk about the possible outcomes from this new experiment where we toss the coin twice. We have 4 different outcomes, which are HH, HT, TH, and TT. So HH here means getting heads on the first toss and heads again on the second toss. Or if you're thinking about throwing 2 coins, then it means getting heads on one coin and heads also again on the other coin. Okay, so that's what these letters mean. So then the number of possible outcomes in this experiment is simply going to equal to 4. And now we're ready to ask our question, which is, what is the probability of coin landing on heads on the first toss and heads again on the second toss? First of all, you should note that it is definitely possible to satisfy both individual events at the same time if we get HH as an outcome. In other words, in this question, we are not dealing with a 0 probability event. We just have to figure out what the probability is. So to answer our question, I'm going to begin with the equation P of HH, which means probability of heads on the first toss and on second toss as well. And here, you should note that these 2 individual events are independent events because coin tosses are independent. So whenever you have independent events and if you have an AND statement, you can use the following equation, which says that P of HH equals P of heads on the first toss times P of heads on the second toss. And when you're calculating the probabilities of the individual events, for instance, when you're calculating the probability of getting heads on the first toss, you can simply focus on that event all by itself.
In other words, you can calculate the probability as if you're tossing the coin only once. So then probability of getting heads on first toss is simply going to equal to 1/2. And it's the same story for the other individual event. If we focus on that individual event all by itself as if we're throwing the coin only once, then probability of getting heads on the second toss is simply going to be equal to 1/2. So with independence, we can then say that P of HH equals 1/2 times 1/2, which equals 1/4. But you must remember that we can only do this because coin tosses are independent. Without independence, we cannot use this equation. Now, before we move on to the next question, I want to point out that P of HH equals P of HT. And that's because probability of getting heads on the first toss is 1/2, and probability of getting tails on the second toss is also 1/2. So if you multiply those two, you end up with 1/4. So I hope it's clear that probabilities of all four outcomes are all equal in this particular experiment. Finally, you should remember that sometimes you're not going to have an AND statement in the question, but it's still going to work as if you have an AND statement in the question. For instance, the question, what is the probability of getting heads on the first toss, but getting tails on the second toss, is really the same as asking what is the probability of getting heads on the first toss and tails on the second toss. So just keep that in mind. Okay, our next question is now asking what is the probability of landing on the same side for both tosses?
And of course, landing on the same side for both tosses mean heads heads or tails tails. So for this question, you want to start with the equation P of HH or TT, which is going to equal to P of HH plus P of TT. Since HH and TT are two separate events, we just have to add the two probabilities. And we just saw in the previous question that P of HH and P of TT are both going to equal to 1/4. So this equation then becomes 1/4 plus 1/4, which equals to 1/2. Okay, moving to our next question, we are now asking what is the probability of getting at least one tails after tossing the coin twice? So then I'm going to begin with the equation P of T at least greater than 1, which is the same as probability of getting at least one tails. Here, if you think about it, probability of getting at least one tail equals probability of getting one tails or getting two tails. Now, the individual event getting one tails involves two outcomes, which are HT and TH. And the other individual event getting two tails involves TT, getting tails tails. And since HT, TH, and TT are all different or separate outcomes, this means that the individual event getting one tails and the other individual event getting two tails, these two events are going to be separate events. And since they are separate events, we can simply add the probabilities of these two individual events. So then if we do that, we're going to get that the probability of getting at least one tails equals P of one tails plus P of two tails, which then equals P of HT plus P of TH plus P of TT. And since we already know that the probabilities of all the outcomes here are equal to 1/4, the solution to this question is going to equal to 1/4 plus 1/4 plus 1/4, which then equals to 3/4. Now, before moving on to the next question, I just want to share with you all that probability of getting at least one tails is going to equal to 1 minus probability of getting less than one tail. And that's because P of at least one tail plus P of less than one tails is equal to 1. We just saw in this question that probability of getting at least one tail equals P of HT plus P of TH plus P of TT, right? We just did that. Now you should note that probability of getting less than one tails equals probability of getting 0 tails, which then equals probability of getting heads heads after throwing the coin twice. So then if you look here, we have 4 events, HT, TH, TT, and HH. And these 4 events make up the entire space of total possible outcomes from our experiment. That means that if you add the 4 probabilities that you see down there, you're going to end up with 1. And that's exactly why probability of getting at least one tails is going to equal to 1 minus probability of getting less than one tails. Okay, we are now ready to ask our next question. What is the probability of getting at least one tails or getting different sides after tossing the coin twice. So then let's first think about our event, and I'm going to call it event Q, and that's going to be getting at least one tails or getting different sides. So getting at least one tails we know involves three separate events, which are TT, HT, and TH. Now getting different sides involves two separate events, which are HT and TH. So if you look here, whenever we get the events or outcomes HT or TH, then the individual event getting at least one tails and the other individual event getting different size are both going to be satisfied at the same time, right? It's possible for the two events to be satisfied at the same time because they share two same outcomes, which are HT and TH. So what this means is that the two individual events getting at least one tails and getting different size, those two are not separate events. And since they're not separate events, we cannot simply add the probabilities of the 5 outcomes that you see in the middle. So I guess there are a couple of ways to solve this question, but one solution is to simply add the probabilities of all 5 events or outcomes in the middle that you see, and you're simply going to subtract P of TH and P of HT to avoid overcounting of probabilities. And the reason why we subtract P of TH and P of HT is because the two outcomes, HT and TH, they're the ones causing these two events not to be separate events. So these two outcomes are the ones causing the overlap, and so we want to subtract the probabilities of these two outcomes in order to avoid overcounting. And so if we do that, then we're going to get that probability of event Q is going to equal to the following equation. And that's going to give us P of TT plus P of HT plus P of TH, which is then going to equal to 3/4.
Now for our next question, I'm simply going to use the same question that we just finished, but I'm going to replace the OR here to AND. So we're trying to find the probability to event W, which is getting at least one tails and getting different sides after 2 tosses. Since we now have an AND statement, we want to figure out if and when the 2 individual events can be satisfied at the same time. To figure that out, note that just like before, the individual event getting at least one tails is satisfied with any one of these 3 outcomes. And the other individual event is satisfied with these 2 outcomes. So as you can see, HT and TH represent overlap or intersection between the 2 individual events. So whenever we get HT or TH, the 2 individual events will be satisfied together at the same time. That means that probability of event W is equal to P of HT plus P of TH, which then equals to 1/4 plus 1/4, which is 1/2. So 1/2 is the answer to this question. Now here, I want to point out that just because we have an AND statement in the question, we cannot say that probability of event W equals probability of getting at least one tails times probability of getting different sides. In this question, we cannot use this particular equation because the event getting at least one tails and the other event getting different sides are not independent. In other words, given information of one event, probability of the other event occurring changes. For instance, if someone told you that the 2 coins landed on different sides, then probability of getting at least one tails, it changes to 1, since HT and TH both contain at least one tails. The point I'm trying to make here is that the 2 individual events are not independent events, and therefore we cannot simply multiply the probabilities of those 2 individual events to get probability of event W. Alright, now we are going to move on to a whole new experiment where we toss the coin 5 times.
So now it's getting really interesting and a little bit difficult. And for this new experiment, you can also think about the experiment where you toss 5 coins at the same time. All the possible outcomes and all the calculations are going to be the same. Okay, since we have a new experiment, we want to think about the total possible outcomes. And I listed 2 of them, which are getting 5 heads, and the other one is tails, heads, and tails. So as you can imagine, in this new experiment, we're going to have many different possible outcomes. So it's simply going to be too much work for you to be writing out all the different possible outcomes. So we're not going to be doing that. But we can, however, easily come up with the number of possible outcomes, and it's simply going to be 2 raised to the 5th power. Okay, I think we're ready for our first question, which is what is the probability of getting 5 heads? And you should note that this is the same as asking the question, what is the probability of getting heads on the first toss and heads on the second toss and on the third and fourth and fifth as well. So they're the same question, okay? So we have an and statement. That's what I'm trying to say. So then I'm going to say that probability of getting 5 heads is equal to the following equation. So you should remember that I am able to use this equation because I'm assuming that the coin tosses are independent. And since probability of heads for each toss is 1/2, probability of getting 5 heads is going to equal to 1 divided by 32. Also, you can check for yourself that probability of getting 5 heads is going to equal to probability of getting 5 tails, which is also going to equal to probability of each outcome in the experiment. Our next question is now asking, what is the probability of getting at least 2 heads after throwing the coin 5 times? So then I'm going to start the equation with probability of getting at least 2 heads. And here, if you think about it, if you try to come up with all the different possible outcomes that satisfy the event getting at least 2 heads, then it's simply going to be too much work. Solving the question in this way is not going to be a good idea. So then you want to think about a different way to solve this question. And one quicker way that I can think of right now is to use the following equation. Probability of getting at least 2 heads equals 1 minus probability of getting less than 2 heads. And here you should note that the event getting less than 2 heads involves 2 other events, getting 0 heads and getting 1 heads. So then this equation becomes 1 minus probability of getting 0 heads plus probability of getting 1 heads. And you should note the brackets here. And how do we get probability of 0 heads? Well, if you think about it, probability of 0 heads equals probability of getting 5 tails, right? And we know already that probability is equal to 1 divided by 32. Now, how do we get probability of getting 1 heads? Well, if you think about it, that's going to be the sum of the 5 probabilities that you see at the bottom of the screen. If you look at the 5 outcomes over here, each one of them contains only 1 heads. So that means that in order to get the probability of 1 heads after throwing coin 5 times, we simply have to add the probabilities of these 5 outcomes, which is going to equal to 5 divided by 32. Now, if we put all this information together, we are going to get our final solution that says probability of getting at least 2 heads after 5 coin tosses is going to equal to 1 minus 1 divided by 32 minus 5 divided by 32. We are now going to ask our final question in this video, which is, what is the probability of getting heads on the first toss and heads or tails on the second toss and at most 1 heads on the last 3 tosses? And so this huge confusing question is asking us to compute this probability. Whenever you get a question like this, my personal recommendation is not to think about all the possible outcomes that can satisfy this very large confusing expression. So personally, I would try to break this expression down one by one. Specifically, I'm going to focus on the 3 individual events over here that are underlined, and I'm going to use the fact that the tosses are independent. And so if we do that, we're going to get that this large expression is going to equal to this equation. So if we look at our first event, probability of getting heads on the first toss, well, that's simply going to equal to 1/2. Now, what about the individual event in the middle? Probability of getting heads or tails on the second toss. So probability of heads or tails on the second toss is simply going to equal to probability of heads on the second toss plus probability of tails on the second toss. And since both of them are equal to 1/2, we're going to get the answer 1. Now we can move on to the final individual event. So probability of getting at most 1 heads on the last 3 tosses, if you think about it, is going to equal to probability of getting 0 heads on the last 3 tosses plus probability of getting 1 heads on the last 3 tosses. And that's going to equal to P of TTT. So that's probability of 0 heads on the last 3 tosses. And then we also have to consider P of HTT, P of THT, and finally P of TTH as well. Now, recognizing the fact that each one of these 4 probability is going to equal to 1 divided by 8, the answer to probability of getting at most 1 heads on the last 3 tosses is going to equal to 4 divided by 8, or 1/2. So then now, if we put together all this information, all the calculations that we have done now, then our final solution to our final question is going to be 1/2 times 1 times 1/2.